Forensic Science Lecture 16-5, Preserving of Developed Fingerprints. Once a latent print is visualized, it needs to be permanently preserved so that it can then be used for future comparison, and then later on within the court as evidence as well. But photographs must be taken before any attempt to preserve it is carried out. If the object is small and can be transported without destroying the print, it should be preserved in its entirety. However, if the print is on a large immovable object, prints are preserved by what we refer to as lifting with a broad adhesive tape, which we'll talk about in a moment. But the most common type of lifter is very similar to Scotch tape. So fingerprint patterns are applied to a print, and this is to visualize them. Once they visualize them, what they need to do to lift them is cover that surface with the adhesive side of the tape, and the powder is then transferred to the tape when it's pulled up. The tape is then placed on a properly labeled card. It must be properly labeled so that all information is known of where that print came from, and so on. And then it's submitted as evidence. The alternative methods include using an adhesive-backed clear plastic that's attached to a colored cardboard backing, but it's still recovered or lifted in the same manner as it is with the tape. Digital imaging for fingerprints have actually played a huge role in the quality of fingerprinting, as prints are usually not perfect when they are lifted from the scene, but now digital imaging has the ability to enhance the analysis process. And so a digital imaging is a process by which a picture is converted into digital computer files, and those files are composed of electronic dots that we refer to as pixels, and those pixels can be manipulated. The resolution of the image is based on the number of those pixels. The larger the number, the closer the image resembles the real world image, and the better the analysis can be. The physical pictures are put into a digital system either through a scanner, by using digital cameras nowadays, as well as video cameras. The brightness and the contrast can be enhanced by a method that's known as spatial filtering. Low-pass filters eliminates harsh edges of the pixels, and then high-pass filters can exaggerate intensity between neighboring pixels. So it's all based on what needs to be done to produce the better image so that it can then be analyzed. Another process is known as frequency Fourier transform, or FFT, and it's used to identify repeated patterns that can interfere with interpretation. And so patterns can then be either diminished or eliminated to enhance the image that's wanted. So for instance, if you have two prints that are overlapping each other, one print can be enhanced while the other is eliminated, to allow for a better analysis. Also, colored backgrounds can also interfere with analysis, so imaging software does have the ability to remove the background to make that image stand out even more. A function that there is a function that allows only portions of the print to be examined individually. So basically the examiner zooms into the area and examines it more closely within more detail. And then the comparing function is probably one of the most important of the functions. It allows for two images to be side by side so that the examiner can chart the common features on both images simultaneously, and that allows for a better comparison between the two instead of having to look back and forth, back and forth. However, when you're looking at digital imaging, it's only as useful as the image it is working with. And so if the detail is not there on the original image, the enhancement procedures are not going to work. So to make sure that when the print is taken or lifted, it's done to the best of the examiner's ability, and then the photograph also needs to be as clear as possible in order to be able to use that digital enhancing software. This ends lecture 16-5. There is a quiz next class.